Okay, and we're live. So we are currently under quarantine, so we're doing everything online. Our objective is to determine the orbital period, radius, instantaneous gravitational acceleration, and/or velocity of an object in orbit. Okay, so as fast as I can, I'm going to review all of Kepler's laws. We'll look at a couple equations, and then we'll do a couple free responses together. So Kepler's first law just says that every planet moves into an elliptical orbit, so it's like an oval shape with the sun as one of the focuses. And then I've got aphelion and perihelion on here as well. Perihelion just means you're closest to the sun. Aphelion means you're further away from the sun. The other foci, the other focal point of this ellipse would be somewhere around here-ish. Okay. The second law says that if the planets were to have a planet that was orbiting the sun would have an equal amount of time to get from point A to point B, then the sector that it creates would have the same area as any other time interval that is the same length. So what that means is if you were to track Earth going around the sun for 3 days worth of time, the area that it sweeps in that sector that it forms from itself to the sun in that course of the 3 days would be the exact same area as any other 3 days on an orbit. This is the hardest one to understand, I think. So any questions on this one?
No, so it means equal area shows that equal time, right?
Right. As long as you have the same amount of time passing from point 1 to point 2, then point 3 to point 4, if it has the same time passing, will have the same area. Awesome. Okay, then the third one is more of a proof. So if we say that the force of gravity is our gravity between two objects, this is our general form for gravity, is the gravitational constant times mass 1, mass 2 over r squared. And a force is mass times acceleration, where acceleration in this case is a centripetal acceleration, or v squared over r. Then we can set our centripetal force equal to our gravitational force and solve for v. If I do, I would get v squared equals g m over r. That m that was left, is that the mass of the planet or the mass of the sun?
Mass of the sun.
Mass of the sun, right. Okay, so we're on the same page. Then because our velocity is also our distance over time, and our distance would be our circumference around the circle, that would be 2 pi r over your t, which in this case is your period, because that's one distance around the circle. So I can make that a capital T for period. Okay, then we can substitute. So if v is 2 pi over period, 2 pi radius over period, then when I square that, that should be equal to gm over r. So that gives us a new equation here. And if I solve that for my period, I would get period squared equals this, which means the ratio between your period squared and your distance between the two center of masses cubed is always a constant, is always 4 pi squared over gravitational constant times mass of the object you're orbiting around.
That's applied in the universe, right?
Yes. This does work if we're talking about Earth and a satellite as well, or any other large mass on a satellite. The same math will apply. It's only that that large m will be your larger mass. Okay. So with Kepler's 3 laws, we can finish out our gravity equations. We've got our force of gravity that we saw earlier. And because a force is mass times acceleration, we could also say that your acceleration due to gravity is just gm over r squared. Now, because F equals ma would be the mass of your satellite, not the mass of what you're orbiting about, the mass that I have left here, again, is the mass of your larger object. So this acceleration due to gravity, if we're talking about acceleration due to gravity because of the sun, would be mass of the sun. If we're talking about a satellite, or if we're talking about you, if I throw you up, then this would be the mass of the Earth. Okay. Then this first half of equations we just saw when we were solving for Kepler's third law. So all of this line actually we saw with when we were solving for Kepler's third law. So this is, again, gravitational force should equal ma if a is centripetal acceleration. We can use that to solve for velocity. We can substitute for velocity as distance over time, which is a period. And then we can use that to solve for Kepler's third law. Okay, then this last bit is a little bit more interesting. So I've got my potential energy due to gravity, which we've proven in an earlier class. But if we already know the force due to gravity, how would I get to energy?
Force of gravity. Oh, we integrated.
Right. Because your work is your force dot displacement, so I could integrate your force in terms of your displacement, and I would end up getting this. Now, because your gravity is constant, your mass is constant, and your mass 2 is constant, this is really just r to the negative 2 power that we have to integrate, which will end up giving us negative r to the negative 1 power, or our potential energy here. Now, ideally, all of our kinetic energy would convert to potential energy along an orbit. So if we're orbiting, then our total potential energy and our total kinetic energy should balance out to 0. That means, though, that if we have an object that will be able to break orbit, then the kinetic energy will end up being more than the potential energy. This part might be new. But that means that in order to escape an orbit, your escape velocity, the speed you would need in order to do that, would be at least as much as this, which I've gotten from taking your kinetic energy here, 1/2 mv squared, and your potential energy. If I add them together, I should get 0. It's just solving for velocity to figure out how much velocity you would need in order to have more kinetic energy than potential energy, which means your object could break orbit. Okay, now as far as your exam goes, I believe the only things that you were given that are showing right now are this force of gravity equation here, this potential energy due to gravity equation here, and centripetal acceleration is v squared over r. So you are not given a lot of these formulas. However, you can rederive them if you need to. So all the information is on the sheet somewhere, but you will have some work ahead of you. If you want a shortcut, then you can memorize any of the other equations that you want. If you feel like you can derive them from scratch, then feel free to derive them from scratch.
FRQ says how to drive it, right?
Sometimes, yes. So if that's the case, then you'll have to go back and actually plug stuff in. But they'll usually tell you what you're starting with if they're asking you to prove. All right, any questions on anything here?
No.
Cool. Okay, then I'm going to jump over to your second sheet that you have, which is a bunch of gravity free response questions. Ooh. I've got previous work here that I'm going to quickly erase.
Oh wait, you have class from like 9 to afternoon every day.
I've got the class before you is 10:30. Starts at 10:30. Today they ran over until 12, and then it took me until about 12:45 to finish the upload. So this is about as early as I can get.
So what do we do after the class?
After class on course sites, for your Calculus BC class, I've combined it with your physics now. So on course sites, you'll see a new folder that says online classes. If you click that, there's a link to the gravity free response questions to the same page I just sent you. But there's also an upload link that will allow you to upload your responses. You can either upload pictures that you take on your cell phone of the work that you've done on your own, or if you want to use the computer, you can change the Word document and then upload your Word document. But either way works.
Wait, can you say again?
Yes. So on course sites, You are currently in my Calc 2 class on Course Sites. If you look under online classes, there should be a link to, it says Day 1 Physics Gravity, and that has everything that you need to submit.
So today is B-Day, which is physics class, and I have to
Mhm.
finish physics assignment.
Right, so today is B-Day. Your physics assignment will be due on the next B-Day by 9 o'clock. So that is, you have until Wednesday at 9 a.m. to finish your gravity assignment. Okay, then I'm going to do the exact same thing for Calc 2, so same time, same everything. I'm also going to post in the same link on Course Sites just so everything's in one place.
So we're doing pre-calculus tomorrow at the same time.
You're doing Calculus BC tomorrow
BC.
at the same time.
Mm-hmm.
If you want to join us for pre-calc, that'd be 5 o'clock.
Oh wait, can combine? Or I mean,
I can't combine with Calc 1 because they're not doing the same stuff, unfortunately.
just want to move the time somehow.
What time would be ideal for you? So,
Wait, so Korean time is about like 11, 9, so 8
morning or afternoon?
morning.
8 in the morning. Um,
Or yeah, morning
I might be able to do that if we're fast.
8. What?
I think I can do 8 o'clock if we're fast.
Oh,
Let's try it tomorrow. Um,
tomorrow 8 o'clock.
yeah, so that's tomorrow, 8 in the morning, China time, right?
Yeah, I will try to. I will say to my mom so she make sure.
Okay. That would be for Calc BC. Your Calc BC videos are a little bit shorter.
It
Um,
takes less time than this.
I think so, yeah.
Oh, okay.
'Cause there's not really a lot to talk about. We finished all of Calc BC, so we still have a bit of physics left. Okay, so we'll try 8 o'clock tomorrow, and if we finish by 10:30, because I don't have a class at 10:30 tomorrow, then we'll say that's enough time to do 10:30 on B days, where I do have a class at 10:30. Okay, so we'll shoot for 8 o'clock then from here on out. Let me keep going with this one then. So, again, if this is too small, then you can pull up the Word document that I sent either on WeChat or Skype. Okay, so this is starting with 77Q3, if you're reading. We've got two stars of mass m, and they're forming a binary star system so that both stars move in a circular orbit about radius r. We have a universal gravitational constant, g. I want you to use Newton's laws of motions and gravitation to express the speed in terms of r, g, and m. Okay, well, what do I have to do first?
So wait, Newton's law of motion and gravitation to find expression for. Wait, we can just. What if we memorize the equation?
I do think they want you to actually solve here.
Okay,
Although
so here.
I'll check their scoring guide afterwards, though.
Yeah. Okay.
Okay.
Wait. Oh, centripetal force
hmm
is equal to gmm over r squared.
Right. Centripetal force is the gravitational force.
Yeah. So mv squared over r is equal to gmm over r squared.
Okay, I'm going to subscript this one as m2.
Mm-hmm.
So that means this m should be m1 or m2.
M1. No wait. Oh, sorry. So it should be mass of satellite.
Satellite. Okay. I'm going to say m2 is satellite then. So this is also m2. Okay. And then, hold on. I believe, yeah, I believe they gave this as a capital R, so I'm gonna make this capital, but yeah. R squared. Now let me go back to your picture for a second, because we need to change one thing. This capital R is really the distance between the two binary stars.
Oh, it should be 2R.
This should be 2R.
Yeah.
Okay.
2R and 4R squared.
Okay. 4R squared. This centripetal acceleration, that radius is your distance to the center. So this R actually won't change. But your gravitational force is your distance to the two center of masses. So this one will be 4R squared.
Yep.
Okay, keep going.
And then we cancel out M2.
Okay.
And then 1R. And then, yeah, and then we just square root of it.
Okay, so our velocity is equal to...
We can take out 2, I think.
Okay, sure. So 1/2.
Have square root gm over r.
Awesome. So that's 1/2 root gm over capital R. I'm going to check. Yes. Okay.
Second question is total energy. So total energy has kinetic energy and potential energy.
Okay, so give me an equation though. So total energy is, again?
Kinetic energy.
Okay. Kinetic energy is how much?
It was minus gm over 2r.
Okay, that's your potential energy I think you're giving me.
Oh,
right?
then it should be positive 1r. gm over r.
GM over R. What are you giving me? I'm sorry.
Oh, wait,
Okay, I'm going to write your potential energy plus kinetic for now, but potential energy plus kinetic. And then let's talk about what each one of these are. So starting with your potential energy. What's our formula for potential energy? Potential gravitational.
wait, it should be one potential is given in the formula sheet.
Okay, it is. So I'll give you that. Here you go.
Oh, that's minus gm1 m2 over r.
Got it. Minus G M1 and M2, which are both the same for this equation. They gave it to us. So your masses are identical. Over, normally this would be R, but which R is this? Is that your distance between the center of masses, or is that your distance to the center of the orbit?
Distance from center to the other planet.
From center to the other planet. Center of what?
Center of moon to center of satellite. Center of sun to center of the other planet.
Okay, cool. So in this case, this is actually 2 times R, since if I go back to our picture, 1 R is only half of your distance between the center of masses. Okay. And then, how about kinetic energy?
Kinetic is gm m over r.
GM over R. Okay, that's your potential energy, I think.
It was similar to potential energy.
If you think back to kinematics, what would your kinetic energy normally be?
1/2 mv squared.
1/2 mv squared. Okay. So I'm gonna have 1/2 mv squared. But then we've got 2 objects this time. So we'll have double that in kinetic energy.
Mm-hmm.
Okay, so let's keep going from there.
Then we just add it, simplify.
Add and simplify. Okay, I was told we need to get this in terms of R, G, and M. So I've got some variables we can't use.
Oh, and then we plug in we found from A.
Perfect. So we're going to take our V that we have here, and we'll substitute that in here. Okay, so what does that give us?
So, so first, I mean the first term, we just copy it.
Okay, negative G over 2R.
Plus that's just mv squared, and then if we square it, no, if we square it, then it's 1/2. It's m times 1/4 gm over r.
Okay, we are very close to getting a common denominator.
Yeah. Oh, and then we times 2 for the first one.
Okay, cool. So that gives us negative 2GMM over
4r.
plus GMM over 4R.
Yeah, then that's just minus gmm over 4r.
GMM over 4R. Okay, I'm going to double check. Minus GM squared over 4R. Yep, okay. Awesome. Any questions on either A or B? I'm going to zoom out so we can see everything really quick.
Nope.
All right, cool.
B.
I don't think so. I think it's just when I copied it over, I didn't copy it right. But that's my bad. Okay, we're on 30 minutes right now. Okay, that's about as far as I want to go, actually. Okay, because 30 minutes, you've got quite a bit of work this time around. Okay, I'm going to break here. That's going to give us... right now in course sets, you've got a bunch of gravity free response questions, which is this document that I just uploaded. I've also got the multiple choice from Barron's. So right now, though, I've got 4 free response questions and 10 multiple choice, which I think is quite a bit. So pick any 2 of those free response questions that you want to do.
Wait, let me log into course site right now. So
I've sent you everything on WeChat as well, so it's the same stuff. So if you look up the gravity free response questions on WeChat, so I want you to pick any 2 free response questions that are not the one we did today, so that's 1977, and complete that one. Then I'm also going to send you a set of multiple choice questions to finish. I believe this document also has 1 free response question. You don't need to do the free response, just the multiple choice part.
also, the one that you posted in here is homework, and do it at the other one.
Yep. Okay. So the gravity FRQ on WeChat. Pick 2 free response and finish. The gravity drill. I need you to finish the multiple choice.
Oh, 10 questions.
I think there's 10. I don't remember.
Okay.
Yeah, 10 questions, multiple choice, and the drill. Okay, cool. I'll post it to WeChat, just a reminder. And once the video finishes uploading, I'll send you the video as well, in case you want to go back.
This video?
Yep.
Okay, thank you.
Thank you very much. I'll see you tomorrow.